This World War II bomber flew home with its tail literally hanging off, and everyone survived. In 1943, at 27,000 feet above the Tunisian desert, a German fighter traveling at 400 miles per hour was about to collide with an American bomber carrying 10 men. Lieutenant Kendrick Bragg had 2 seconds. Maybe less. He could see the Messerschmitt Bf 109 filling his windscreen, not banking away, not pulling up, but coming straight at the rear of his aircraft like a steel dart. He rammed his controls forward. It was not enough. The impact, when it came, was a sound that none of the surviving crew would ever fully describe. Not an explosion. Not a crash. Something more structural, a tearing, grinding, wrenching sound that ran the entire length of the aircraft, like the spine of something enormous being broken. When it was over, the All-American was still in the air. Somehow. Barely. The German fighter had disintegrated. But what it had left behind, embedded in the rear fuselage of Bragg's B-17, was a wound that no aircraft was supposed to survive. A gash 16 feet long and 4 feet wide, a diagonal tear from the base of the vertical stabilizer running almost to the radio compartment. The entire tail section hung at an angle, connected to the rest of the aircraft by 2 thin strips of aluminum and a mounting bracket that had no business being structural. And trapped in that tail section, with no floor beneath him and nothing but twisted metal and open sky between himself and the Tunisian desert 5 miles below, was Staff Sergeant Sam Sarplis. He could not reach his crew. His crew could not reach him. And the aircraft had another 600 miles to fly before it would reach its base in Algeria. What happened over the next 2.5 hours would produce one of the most famous photographs of the Second World War, and one of the most extraordinary survival stories in the history of aviation. But it would not happen through luck. It would happen through the deliberate, methodical, desperately improvised decisions of 10 men who had made a silent agreement with each other that none of them would go home alone. This is the story of the All-American. To understand what happened on February 1, 1943, you need to understand what a B-17 flying fortress actually was, and what it was like to climb inside one and point it toward Nazi-occupied territory. The Boeing B-17 was designed to do something that most aviation engineers of the 1930s considered borderline suicidal: fly in broad daylight over heavily defended targets deep inside enemy territory, drop bombs with precision, and fly home again. It had a wingspan of 103 feet. It weighed 65,000 pounds fully loaded. 4 Wright R-1820 Cyclone radial engines, each producing 1,200 horsepower, drove it to a maximum speed of 287 miles per hour at altitude and a service ceiling of 35,600 feet. It carried between 11 and 13 Browning M2.50 caliber machine guns, positioned in turrets and waist positions to cover virtually every angle of approach. None of those numbers are what made the B-17 famous. What made the B-17 famous was what it could absorb and keep flying. Its airframe was built around a central structure of thick aluminum longerons and formers that gave it structural integrity well beyond what the engineers had technically specified. The skin was thick enough to deflect small caliber rounds. The systems were redundant: 2 hydraulic systems, 4 independent engines, multiple electrical circuits. Stories circulated throughout the Army Air Forces of fortresses returning from missions with engines shot out, control surfaces destroyed, fuselages riddled with holes, yet still bringing their crews home. The All-American was a B-17 F-5BO, serial number 41 to 24406, assigned to the 414th Bombardment Squadron of the 97th Bombardment Group based in Algeria. The 97th had achieved a particular distinction. It was the first American heavy bombardment group to conduct daylight bombing raids over occupied Europe, hitting German railway yards near Rouen, France on August 17, 1942. Lieutenant Kendrick Bragg was 21 years old. He had played football at Duke University before the war. His crew included co-pilot 2nd Lieutenant G. Boyd Jr., navigator Harry C. Newsell, bombardier Ralph Burbridge, and 6 enlisted men who manned the guns and vital systems. They had named their aircraft All-American because the crew came from every region of the country: farm boys from Kansas, factory workers from Detroit, college students from California. They had forged the kind of trust that only comes from regularly facing the genuine possibility of dying together. On the morning of February 1, 1943, they climbed into their aircraft for what was briefed as a standard mission: a daylight precision bombing attack against German-controlled seaports at Bizerte and Tunis. Routine, by Mediterranean theater standards. Nothing about what followed would be routine. The briefing for February 1st covered the usual elements: target coordinates, expected flak concentrations, fighter cover, emergency procedures. The targets at Bizerte and Tunis were strategic: German supply ports feeding the Axis forces fighting the Allied advance across North Africa. Destroy the ports, slow the supplies, shorten the campaign. The arithmetic of strategic bombing. The formation climbed out of Algeria in pre-dawn darkness and assembled over the Mediterranean. Flying at 27,000 feet, the bombers entered the bomb run, the most dangerous phase, when the aircraft had to fly straight and level on a predetermined heading while anti-aircraft guns below worked out their trajectory. Black bursts of flak appeared around the formation, close enough to smell cordite and hear fragments rattling against aluminum skin. Several bombers took hits. The formation held. The bomb bay doors opened. The Norden bomb sights were aligned. The bombs fell away. The aircraft lurched upward as thousands of pounds of ordnance departed the bay. The formation turned for home. The Messerschmitts were waiting. Two Bf-109 fighters from Jagdgeschwader 53, veterans with years of combat experience over North Africa, intercepted the formation as it turned west. Lieutenants Julius Meinberg and Eric Paxier employed the head-on attack, the most dangerous tactic in fighter versus bomber combat. Coming straight at the bombers at combined closing speeds exceeding 500 miles per hour, they had perhaps 3 seconds to aim and fire before breaking away. The advantage was that this approach presented the bomber's most vulnerable aspect, the cockpit and nose, while the defensive fire was least concentrated. Both B-17s responded with everything they had. 10.50 caliber machine guns filled the airspace ahead with tracers. The German fighters flew straight through it. Meinberg's oxygen system caught fire. He bailed out with severe burns and spent months recovering in Germany. He survived. He was lucky. Paxier's aircraft was also hit. Whether by the All-Americans guns or fire from the lead bomber, the records are unclear. What is clear is that the hits caused him to lose control at the worst possible moment. A Bf-109 that stops responding to its pilot while traveling at 400 miles per hour toward a Boeing B-17 becomes, in aerodynamic terms, a guided missile with no guidance system. The fighter's wings struck the All-American's rear fuselage. The next sound Kendrick Bragg heard was the end of everything he had planned for the day. The photographs taken afterward, by a P-38 pilot who drew alongside the struggling bomber hours later, show something that the human mind resists categorizing as an aircraft that is still flying. They look like something from an industrial accident, a manufacturing error, a controlled demolition that stopped halfway through its work. The Bf-109's wing had struck the All-American's rear fuselage at an angle, tearing a diagonal gash that began at the base of the vertical stabilizer and ran forward and downward for 16 feet, opening a hole 4 feet wide at its widest point. The German fighter had disintegrated on impact, its engine, its cockpit, its fuel tanks, all of it gone in fragments that embedded themselves in the B-17 structure. Eric Paxier, whatever his condition had been at the moment of impact, did not survive. The structural damage to the All-American was catastrophic by any reasonable engineering assessment. The left horizontal stabilizer, one of the 2 horizontal tail fins that provide the aircraft's pitch stability, that keep the nose from pitching up or down uncontrollably, had been completely severed. Gone. Not damaged. Gone. The vertical stabilizer and rudder, which provide directional control, were severely compromised. The control cables that ran from Bragg's control column in the cockpit all the way back to the tail surfaces, the physical connections between pilot input and aircraft response, were mostly severed. What remained was a handful of cable strands and a structural framework that had never been designed to hold together with a 16-foot hole in its side. Both right engines were knocked out. The left outboard engine had a severe oil leak and was running rough. The aircraft now had, in practical terms, between 1 and 2 functional engines out of 4. The radios, electrical systems, and oxygen equipment in the rear of the aircraft were destroyed. The hydraulic lines were cut. And Staff Sergeant Sam Sarpoulos was in the tail gunner's position, a small, cramped compartment at the very rearmost point of the aircraft, with no floor connecting him to the main fuselage. The collision had effectively isolated him. The damaged tail section swayed and twisted in the slipstream, moving independently of the rest of the aircraft in ways that no tail section of any aircraft was designed to move. Sarpoulos could feel the entire structure flexing with each slight change in airspeed or heading. He could look down through the gap in the fuselage and see, 5 miles below, the Tunisian desert. He had no way to move forward. His crew had no way to reach him. And any significant physical disturbance to the tail section, a crew member trying to crawl back to him, a sudden control input from the cockpit, a particularly aggressive defensive maneuver, might cause the entire tail to separate from the aircraft. In the cockpit, Kendrick Bragg took stock of what he had. 2 engines, maybe. A control system that was mostly theoretical. A structural connection between the forward fuselage and the tail section that amounted to 2 strips of aluminum and 1 mounting bracket. 10 men, all currently alive, all currently committed to whatever happened next. He chose to fly home. The decision to attempt a return flight rather than order the crew to bail out was not made in a single moment of dramatic clarity. It was made incrementally, as Bragg and his crew assessed each problem and found responses that were barely adequate but just sufficient to justify continuing. The first problem was control. With most of the elevator control cable severed, Bragg could not move the control column through its normal range without risking complete disconnection of the remaining cable strands. Every input had to be gentle, not the smooth, confident corrections of a pilot in full command of his aircraft, but the tentative, minimal movements of a man trying to coax a response from something that might stop responding at any moment. He and co-pilot Boyd worked the throttles continuously, using differential engine power to supplement what little remained of the aerodynamic control system. Increase power on the right engines, the nose yaws right. Reduce power on the left, the aircraft descends slightly. It was exhausting, imprecise, and completely unlike anything either man had been trained for. The second problem was the tail. Sapolis, in his isolated position, discovered something critical almost immediately. His presence in the tail section was providing stability. His weight, roughly 180 pounds plus equipment, was acting as ballast, damping the oscillations that the damaged structure was generating in the slipstream. Any attempt to extract him might make the tail oscillation worse, might shift its resonance to a frequency that the remaining structural connections could not absorb. He stayed where he was. He stayed, and he kept his guns operational, and he waited. The third problem was the fighters. German Bf-109s, seeing a damaged B-17 fall behind the main formation and begin losing altitude, did what German fighters were supposed to do. They attacked. A struggling bomber, separated from its formation and clearly unable to maneuver, was the kind of target that fighter pilots train for. Under normal circumstances, it would have been a straightforward kill. The circumstances were not normal. The All-American gunners were all still alive and all still armed. The waist gunners, Staff Sergeants Michael Zuck and the others manning the lateral positions, found themselves in a situation with no precedent in their training. The gaping hole in the top of the fuselage meant that their normal operating positions were partially exposed to the open sky. They improvised. They stood with their upper bodies protruding through the hole, using the torn aluminum edges of the fuselage as a platform, and they fired. Sapolis, in the tail, faced the most constrained situation. He could fire only in short bursts, because the recoil from his twin .50 caliber tail guns was producing a measurable yaw response in the entire aircraft, a shudder that ran forward through the damaged structure and registered on Bragg's control column as a sudden, unexpected input. He learned to time his bursts. Short, controlled, disciplined. Not because he was conserving ammunition, but because he was, in a very real sense, trying not to shake his aircraft apart with his own weapons. The German fighters made their attacks and broke away. They came again and broke away again. The formation of a healthy B-17 with its full complement of functioning guns, 13 weapons capable of firing simultaneously, was too dangerous to press home and attack against. The All-American, crippled and falling behind, should have been easy prey. But the gunners held their positions, and the fighters, after several passes that produced no kills, eventually gave up and looked for easier targets. Meanwhile, the crew was physically attempting to hold their aircraft together. Parachute harnesses and shroud lines, the nylon cords that connect a parachute to its wearer, were cut from the emergency chutes and used as improvised lashings around the damaged fuselage structure. Metal fragments from the German fighter that had embedded themselves in the B-17's aluminum skin were extracted and used as improvised splints across the torn edges of the hull. The crew worked systematically, not in panic, identifying each point where the structure seemed most likely to fail and applying whatever material was available to reinforce it. This effort had a secondary consequence that the crew understood clearly and accepted without discussion. The parachutes used for this work were no longer functional as parachutes. If the aircraft became uncontrollable before reaching base, if the tail finally separated, if the engines finally quit, if Bragg finally ran out of control inputs to keep the damaged machine level, the men who had cut up their chutes would not be able to bail out. They had made a decision, by the act of cutting those cords, that they were committed to the aircraft. There was no halfway option anymore. They kept working. While his crew improvised their way through the structural crisis behind him, Bragg was doing mathematics. The All-American had departed on a mission with roughly 2,700 gallons of fuel, the standard load for a mission of this range. The collision and the subsequent need to fly with greater than normal power settings to maintain altitude, compensating for the lost engines and the massive drag of the open fuselage, were consuming fuel faster than the pre-mission calculations had assumed. The oil leak in the left outboard engine was getting worse, not better. At some point, that engine would either seize or have to be shut down, which would leave the aircraft with a single functioning engine on one side and two on the other, an asymmetric thrust problem that, in a B-17 with compromised control surfaces, might prove impossible to manage. The distance back to their base at Biskra, Algeria, was approximately 600 miles. At the reduced airspeed that the damaged structure forced on them, flying too fast would stress the tail connections beyond their limits. The flight time would be somewhere between 2 and 3 hours. 2 to 3 hours, in an aircraft that everyone on board understood was not supposed to be flying. Bragg could not communicate by radio. The equipment was destroyed. He could communicate within the aircraft through the interphone system, though some connections had been severed in the collision. He could communicate with other aircraft visually, through hand signals and the universally understood vocabulary of aviation emergency signals. The flares, the rocking of wings, the gear up or gear down positions that carried specific meanings in the protocol of the era. He kept the aircraft level. He kept the engines at the settings that produced just enough power without producing enough stress to tear the tail off. He turned toward Algeria. The turn itself became one of the most technically demanding maneuvers of the entire ordeal. With normal aileron and rudder control unavailable, any bank more than a few degrees risked inducing a roll that the remaining control inputs couldn't stop. Bragg had to execute the turn home, roughly 90 degrees of course change, using differential throttle alone, adding power on one side and reducing it on the other, over a period of time so extended that the aircraft covered nearly 70 miles during a maneuver that should have taken 30 seconds. 70 miles to complete a turn. It was the slowest, most careful, most deliberate navigation in the history of the 97th Bomb Group. The altitude was falling. Not dramatically, not in the uncontrolled descent of a truly dying aircraft, but steadily, a few hundred feet per mile, as the drag of the damaged structure exceeded the lift that 2 engines and one partially functional third engine could produce. Bragg watched the altimeter and adjusted. There was a floor below which he could not go and still have options. He was trying to stay above that floor for long enough to reach Algeria. The P-38 Lightning fighters that intercepted the All-American as it crossed into Allied airspace were from an escort unit providing cover for returning bombers. Their pilots had seen battle damage before, aircraft with engines out, with holes in their wings, with pieces of control surface missing. They had never seen anything like what they were looking at. One pilot drew alongside and looked at the tail section of the All-American from a distance of perhaps 50 feet. He watched the tail sway. He watched the tear in the fuselage flex as the slipstream worked against it. He watched the 2 thin strips of aluminum that connected the tail to the rest of the aircraft bear the entire aerodynamic load of the horizontal stabilizer, a load that, in normal circumstances, required a full structural frame with multiple attachment points. He radioed back to base. "The aircraft will not make it to shore," he reported. "Recommend rescue boats be dispatched." In the cockpit of the All-American, Bragg received none of this transmission. His radios were gone. He was flying by instinct, by feel, by the accumulation of everything he knew about how a B-17 responded to inputs and how this B-17 had redefined those responses. He was somewhere over the Mediterranean, losing altitude at a manageable rate, with Algeria ahead and every system that remained functional being nursed along by 2 men at the controls and 8 men behind them who were either firing guns, holding structure together with parachute cord, or waiting in an isolated tail section and trusting that the aircraft would not come apart before they got home. He had no intention of putting anyone in the water. There is a question the All-American story poses, and that any honest account has to address directly. Why didn't they bail out? The tactical situation at the moment of collision would have supported an immediate bailout order. The aircraft was structurally compromised beyond anything in the emergency procedures. 2 of 4 engines were out. The control system was barely functional. Standard doctrine said, if the aircraft cannot reasonably be expected to return to base, the crew abandons it. Bragg did not give the order. The explanation the crew gave afterward was practical. Several parachutes had been cannibalized for their shroud lines to reinforce the structure, removing the option for some crew members. But this answer is slightly dishonest, because the parachutes were cannibalized after the decision to attempt a return had already been made. The parachute material was not the reason they couldn't bail out. It was evidence of a decision already taken. The actual reason was Sarpless. Staff Sergeant Sam Sarpless, in his isolated tail section with no floor beneath him and no way forward, could not bail out. The gap between his position and the nearest exit was bridged by nothing except open air and the drop toward North Africa. A man cannot jump from an aircraft he cannot reach the door of, and any attempt to improvise a path to him would risk disturbing the structural equilibrium keeping the tail attached. Sarpless had not asked to be saved. He had kept his guns trained rearward and continued to do his job. Short bursts timed to minimize the best defensive contribution he could make from his impossible position. The crew had not discussed saving him in any formal sense. There was no vote, no announcement, no dramatic declaration. What there was, in the silence between the engine noise and the wind through the fuselage hole, was a simple understanding. 10 men had climbed into this aircraft. 10 men would leave it. 9 of the 10 men in the All-American could have exited at any point after the collision. 9 of the 10 chose not to. The choice was not articulated. It was simply made, and held to, for 2.5 hours while the aircraft slowly crossed the Mediterranean and the Algerian shoreline began to appear ahead. When Bragg finally spotted Biskra through the windscreen, he fired his emergency flares, 3 red signals, the universal signal for an aircraft in distress. The ground crews and airmen who watched the All-American come in on final approach would later describe the experience as something they had no framework for. Aircraft that had taken this much structural damage simply did not fly. But there it was, coming in low and slow, the tail section visibly askew, the gaping hole clearly visible from the ground. The landing approach for the All-American required Bragg to solve, in real time, a series of problems that the aircraft's designers had never anticipated needing to solve. The hydraulic system, which normally powered the flaps and landing gear, was severely compromised. Hydraulic pressure is what pushes the landing gear down and locks it into position for touchdown. Without reliable hydraulic pressure, the gear might extend partially or not at all, or it might extend and then collapse on touchdown. The flaps, the hinged surfaces on the trailing edge of the wings that increase lift at low speed and allow the aircraft to land at a manageable velocity, were similarly unreliable. More critically, the tail wheel. A B-17 has 3 wheels, 2 main gear assemblies beneath the wings and a tail wheel at the very rear of the fuselage. The tail wheel keeps the aircraft's tail off the ground during landing rollout, allowing it to maintain directional control until it slows to taxi speed. The All-American's tail wheel could not be extended. The hydraulic lines that controlled it were gone. A landing without the tail wheel meant touching down on the main gear only, then allowing the aircraft to settle tail down onto the runway surface, the damaged, torn, barely connected tail section dragging along concrete at whatever speed the aircraft was still traveling when it made contact. The elevator controls, the primary inputs for controlling the aircraft's pitch attitude on final approach, the angle at which the nose is raised or lowered, were barely responsive. Bragg and Boyd would have to use engine power to manage pitch, adding power to raise the nose, reducing power to let it drop, using the engines as a substitute for control surfaces that no longer fully existed. They flew a final approach that the P-38 escort pilots watching from above found almost unbearable to observe. The aircraft was coming in slower than normal, slower than safe, under any other circumstances, because the damaged aerodynamics required a low approach speed to prevent the tail from departing. It was coming in slightly nose-high, the pitch attitude of an aircraft with inadequate elevator authority trying to maintain enough angle of attack to stay airborne. The approach path was not the smooth, stabilized descent of a trained crew executing a standard procedure. It was the approach path of men doing the best possible thing with the least possible means, and knowing that if they got it wrong, there would not be a second attempt. The runway at Biskra had been cleared of all other aircraft the moment the emergency signals were spotted. Ambulances were positioned along the runway edge. Fire trucks were ready. Medical personnel waited. The ground crew stood and watched because there was nothing else they could do, and because some part of them needed to witness what was happening. The main gear touched down. The aircraft rolled. The nose pitched down gradually as speed decreased, the aerodynamic lift that had been keeping the nose up dissipating as the aircraft slowed. The tail settled. The damaged rear fuselage, the gash 16 feet long, the structural connections that had held for 2.5 hours and 600 miles, made contact with the concrete and dragged. The bomber rolled to a stop. Bragg fired no more flares. He sat in his seat for a moment, and then he and Boyd began the shutdown sequence, fuel cutoffs, ignition switches, the methodical procedure of securing an aircraft after a flight. Normal. Deliberate. As if this were any other landing on any other day. When the ambulances rolled up, Bragg waved them off. All 10 men climbed out of the All-American under their own power. Sarpelis descended from his isolated tail position using a ladder lowered to him from the ground. There were no injuries. Not from the collision. Not from the 2.5 hours of flight in a structurally compromised aircraft. Not from the landing. As the last man cleared the aircraft, the entire rear section of the All-American collapsed onto the runway. The 2 strips of aluminum and the mounting bracket that had held it in place for 600 miles had held it in place for exactly as long as they needed to. The image of the All-American in flight, taken by a P-38 pilot who drew alongside the stricken bomber somewhere over the Mediterranean, became one of the most reproduced photographs of the Second World War. It shows a B-17 in level flight, apparently normal from the front, wings level, engines running, the blunt nose and greenhouse cockpit of the Flying Fortress just as Boeing had drawn it. And then, at the rear of the aircraft, something the eye initially refuses to process. The fuselage simply ends in a yawning diagonal tear, a disconnection between the main body of the aircraft and its tail section so complete that it takes a moment to understand the tail is still attached at all. The left horizontal stabilizer is gone. The vertical stabilizer leans at a slight angle. The tail section appears to float behind the fuselage, held by connections too thin to be visible in the photograph. The hole in the top of the fuselage is clearly visible, a dark rectangle of open sky in the middle of what should be solid aluminum. And the aircraft is flying. Straight and level. In controlled flight. With 10 men inside. The photograph circulated through the Army Air Forces before public release, and the reaction among men who flew B-17s was specific. They were not surprised in the way civilians were surprised. What surprised them was the nature of this damage, not the concentrated destruction of anti-aircraft fire, but a surgical removal of the components that, by every engineering principle, should have made flight impossible. The photograph went to press in the spring of 1943 and was widely published in American newspapers and magazines. It became a shorthand for the qualities the American public wanted to believe defined their airmen: technological capability, physical courage, and an absolute refusal to accept defeat. The 414th Bombardment Squadron used it as their official emblem, a puppy sitting atop a severed aircraft tail section, reflecting both the miraculous nature of the survival and a darkly sardonic humor that develops among men who fly dangerous missions regularly. There is a persistent popular belief that the All-American Story inspired Coming In on a Wing and a Prayer, written by Harold Adamson with music by Jimmy Maheu and recorded in 1943. The actual inspiration was a different aircraft, another 97th Bomb Group B-17 called Thunderbird, which survived its own harrowing mission to Tripoli in January 1943. A crew member reportedly radioed the tower on approach with the message that they were coming in on a wing and a prayer. The All-American Story was remarkable enough to stand without the borrowed lyric. The context in which the All-American survival story happened is as important as the story itself, a context often sanitized in popular accounts of the air war. The statistics that bomber crews lived with were not abstract. A B-17 crew was required to complete 25 missions before rotation out of combat. In the first year of operations, the probability of completing all 25 was somewhere between 25% and 50%, depending on the period and targets. If the probability of surviving any given mission was roughly 95%, and you flew 25 such missions, the cumulative probability of surviving all 25 was approximately 28%. 3 in 10. Worse odds than any casino game. Of the 12,731 B-17s built during the war, over 4,735 were lost to enemy action and accidents, a loss rate exceeding 37%. The question was not whether any given B-17 would be lost. The question was whether its crew would be alive or dead when it happened. The All-American's crew had already beaten those odds on February 1, 1943. They would continue beating them. All 10 men survived their war service, a result so statistically improbable that it deserves to be stated plainly and allowed to sit without commentary. The bomber itself was repaired and eventually transferred to the 352nd Bombardment Squadron of the 301st Bombardment Group, where it continued flying missions. It was scrapped in March 1945, having survived both the war and its own wreckage. The aircraft described as certainly doomed by the P-38 escort pilots flew for 2 more years. The human cost of the air campaign that these men were fighting was, in aggregate, staggering. The 8th Air Force alone lost 26,000 men killed in action over the course of the war, a casualty rate higher than any other branch of the American military in the European theater. The men who flew these missions knew the numbers. They flew anyway. Not from any extraordinary recklessness or indifference to survival, but because the job required it and because they had made a commitment to each other that transcended the mathematics. Kendrick Bragg understood this better than most. He had made his commitment explicit, on February 1, 1943, by choosing to fly 600 miles in an aircraft that every indicator said could not make it. The choice was not irrational. It was the product of a calculation that included factors the mathematics couldn't capture: his understanding of the B-17 structural behavior, his crew's capabilities, and the simple fact that Sam Sarplis was in the tail and there was no other way to get him home. The All-American Story endured in the culture of the Army Air Forces for reasons that go beyond its dramatic qualities. Every bomber crew that heard the story drew something specific from it, not the generalizable lesson about courage that appeared in every piece of wartime communication until the words became meaningless, but something more concrete, a proof of principle. A demonstration that the B-17 could survive damage that should be fatal. That the machine, for all its vulnerabilities, was fundamentally on their side. This mattered enormously in the psychology of men who flew deep penetration bombing missions over heavily defended targets. The deeper fear was not death but helplessness, the moment when the aircraft stops responding, when damage accumulates past the point where skill and determination can make any difference. The All-American proved that this threshold was further away than anyone had a right to expect. That a B-17 with two engines out, with a 16-foot hole in its fuselage, with its tail section held on by two strips of aluminum, could still be flown. That the boundary between survivable and unsurvivable was not where the physics textbook said it was. This was not propaganda. The photographs were real. The mission reports were real. The aircraft had been seen in flight by multiple escort pilots who filed their own reports. The landing had been witnessed by the entire ground complement at Biskra. The story spread through the 97th Bomb Group and outward through the Army Air Forces not as an inspirational tale but as operational information. The aircraft can take this much damage and still fly. Bragg and his crew were not, in their own estimation, heroes. They were airmen who had encountered an extreme situation and responded to it with the tools available. The aircraft's structural capability, Bragg's piloting skill, the crew's mechanical ingenuity, and the collective decision that they were going home together. None of these were supernatural. All were the product of training, experience, and the culture of mutual responsibility that the Army Air Forces had cultivated through the brutal shared experience of the air war. After the war, all 10 men went their separate ways. Bragg returned to civilian life in Georgia. Sarpoulos went home to his family. The aircraft was repaired, transferred to the 352nd Bombardment Squadron of the 301st Bombardment Group, flew missions until 1945, and was scrapped in March of that year, having survived both the war and its own wreckage. The 97th Bomb Group, which started the war as the first American heavy bombardment unit to hit occupied Europe, ended at having flown 562 combat missions, dropped 18,925 tons of bombs, and lost 184 aircraft in combat. Among its many missions and many survival stories, the All-American remained the most famous. Not because of any song, not because of a photograph, but because of 10 men who looked at the mathematics and decided the mathematics was missing a variable. The variable was that they were not going to leave Sam Sarpoulos in that tail section. And they didn't. The B-17 Flying Fortress was not the most advanced or capable heavy bomber of the Second World War. The B-24 Liberator had greater range. The Lancaster could carry a heavier bomb load. The B-29 Super Fortress operated at altitudes and ranges that the B-17 could not approach. What the B-17 had, in a way that its specifications cannot fully capture, was a particular relationship with the men who flew it. Boeing's engineers had built the B-17 with structural margins that exceeded their specifications, partly from caution and partly from the engineering culture of an era without computer-assisted structural analysis, where conservative design was the only available insurance. The longerons forming the B-17's backbone were sized for loads significantly greater than the aircraft was expected to encounter. The skin was thicker than the minimum requirement. The attachments between major structural sections were multiply redundant, designed so that a single failure would not cascade into catastrophic loss. On February 1, 1943, those design margins were tested to their absolute limits and found to be exactly sufficient. 2 strips of aluminum and a mounting bracket held the All-American's tail in place for 600 miles because the engineers who had sized those components had built in a safety factor that nobody expected to need. But the safety margin was not enough on its own. The B-17 could absorb the damage, but it still needed Bragg's hands on the controls. It still needed Sarpoulos holding his position in the tail. It still needed the waist gunners improvising firing positions in the hole. It still needed the crew cutting up their parachutes and accepting what that meant. The machine and the men were each necessary conditions for survival. Neither was sufficient alone. The statistical reality of the air campaign frames the achievement precisely. Of the 12,731 B-17s built during the war, over 4,735 were lost to enemy action and accidents, a loss rate exceeding 37%. A B-17 crew was required to complete 25 missions before rotation. In 1943, the probability of completing all 25 was somewhere between 25% and 50%, depending on the period and the targets. All 10 men of the All-Americans survived their war service. The mathematics of that outcome is left as an exercise for the reader. Kendrick Bragg died in 2012, at the age of 91. He had outlived most of his crew, outlived the aircraft that had brought him home, outlived the war that had defined the most dramatic day of his life. For decades, people ask him what it had felt like to fly home in the All-American. His answer was always some version of the same thing. He had a job to do. He did it. He brought his crew home. He saw nothing remarkable about that. The crew of the All-American would disagree. The 10 men who climbed out of that aircraft at Biskra, the aircraft that finally collapsed behind them as if it had been waiting for permission, would say that what happened that day was entirely remarkable. That the B-17 held together because it was built to hold together, and that they held together because they were committed to each other, and that those two facts combined to produce a result that the mathematics said was impossible. They were right about all of it. The All-American flew home on a structural margin, a crew decision, and 2 strips of aluminum. It was enough.